Hello everyone, welcome back. In this session, I am going to discuss about the classification of fuel cells. As we know that the fuel cells will supply the energy in the form of electricity, and that can be used for the different applications, and particularly the fuel cells are used to supply the energy to the vehicles. And here the different types of the fuel cells, what are there, how those are classified, and their classification I am going to discuss. The fuel cells come in many varieties. However, they all work in the same general manner. Their working is same in the general manner. A range of fuel cell designs using a necessary electrochemical conversion. In that electrochemical conversion or a reaction is taking place, by that only the electricity is producing from that one. Okay, the conversion has been developed to meet the different design and operating criteria. It includes the following performance criteria. Here the following these performance criteria are required, which will satisfy that one, and these criteria, that is the best fuel cell which can be used, and depending upon the availability of the material, catalyst, and the application, the different types of the fuel cells are used, and that I am going to discuss in the further slides. Now I'll take what are the performance criteria are to be considered for the different types of the fuel cells. The first one is the less expensive construction, more efficient fuel utilization, faster startups, use of more convenient or less expensive fuels, achieving higher power outputs, operating temperatures, choice of catalyst, electrodes design. These are the required criteria are there which will be considered for the different types of the fuel cells. Now we take the different types of the fuel cells. Okay, that these fuel cells, the first one is the which type of fuel cell is there. Okay, that which type of the electrolyte is used, and the temperature range, the fuel which is used, and advantages of that one, and the what are the problems associated with those fuel cells. That I will tell that one. The first one is the polymeric, that is called as a PEMFC, that is a proton exchange membrane fuel cell. That is a proton exchange membrane fuel cell, and here that is electrolyte water is going to use, that is polymeric membranes, and the temperature is 3200, and fuel use is a hydrogen, that is H2. It is having the advantage of fast start of solid electrolyte is used. Pure hydrogen is needed, expensive catalyst. Okay. That here the pure hydrogen is needed, and catalyst also expensive in this one. And second one, direct methanol fuel cell, and there also the polymeric membranes electrolyte is used. The temperature range is 3200, and fuel whatever is this C3OH, ethyl alcohol is used here, and the advantage is liquid fuel is used, that is ethyl alcohol, and no reforming stuffs for the fuel. No reforming stuff is considered there. The reaction is slower on problem. Fuel crossover from the anode to cathode. Not the fuel only directly crosses from the anode to the cathode. That is the difficult associated. Then next one is alkaline fuel cell, and KOH liquid is used as the electrolyte, and temperature is 65 to 220 degrees Celsius, and KOH is fuel also, and it is having the advantage of better current response. The current flow response will be better. There is a fast cathodic reaction. The reaction will be faster. The reactants must be removed. What are the reactants are there? Those to be removed. Okay. That is one of the problem associated with that one. Next one is the phosphoric acid fuel cell. The electrolyte is H3PO4, the phosphoric acid, and there here temperature range is 150 to 220, and hydrogen fuel is used. High efficiency with heat cogeneration. It is producing a high efficiency electricity. Also heat it will be producing within the cogeneration. Low power and current expensive catalysts. Even though efficiency is higher, the power output will be lower on this one. And expensive catalyst. The catalyst what we are going to use, that is the electrolyte, that is expansion. The next one is the molten carbonate fuel cell. And carbonates like lithium, sodium, okay, potassium, these are used as the carbonates as the electrolytes. Temperature range is high here. What we can note that is 600 to 1000 degrees Celsius. Hydrogen fuel is used, better conductivity, high current density. Better conductivity is there, high current density is there. Slow startups will be there, and material problems. Those materials having the problems regarding availability and utilization. Next one is a solid oxide fuel cell. A zirconium and argon is used as the oxygen is used as the electrolyte, and again here also that is temperature is 600 to 1000 degrees Celsius, and hydrogen is used as a fuel, a solid electrolyte. These electrolytes are solid and low cost material. The material whatever is used here, the low cost electrolyte materials, or the whatever the this one carbonates are there, those are less expensive. The material problems, corrosion of a metal. The materials, the availability of the materials will be problem is there, and associated the problem will be there with the material in the reaction in the fuel cell. And corrosion of a metal. By this one, the corrosion of the metal parts which are present in the fuel cell will be taking place. Okay, with this, what are the different types of the fuel cells are there, I have explained. Thanks for watching. If you like the video, share, subscribe and comment.